In this math counts preparation lesson, we are going to be talking about some algebra, so let's get started. So first, we have to talk about the quadratic formula. Right, the quadratic formula is a very important part of math counts, especially once you after the school level, you have chapter competition, and the state competition, and the national competition. Each one of those, the sprint round, countdown, each round of those competitions uses quadratics. There's entire problems dedicated to quadratics on the state competition, and there's some problems which we have to solve quadratic equations in any way you would like. But I think the quadratic formula for math counts is the best way you can solve any quadratic. But if you can go ahead and factor the polynomial. Everyone probably knows how to factor polynomials. If you don't know how to factor polynomials, go to my first video. You should have watched all the previous videos before you come to this video. Anyways, let's get started. So quadratic equations are always given in the form ax squared plus bx plus c, which is all equal to 0. So this is a standard form for any quadratic equation, where a, b, and c are constants. A, b, and c are constants in this equation. They're all set equal to 0. So over here we have ax squared. This is the quadratic term. We have bx, which is a linear term. We have c, which is a constant term. B and c are constants, and x is what we need to solve for. So we can manipulate this to find that the quadratic formula is negative b plus or minus. I'm going to explain the plus or minus in a second. Plus or minus. I should draw a better minus. Plus or minus b squared minus 4ac all over 2a. Now note that you also might see a quadratic equation in the formula x squared plus bx plus c equals 0. But this is also just the same form as this, since in this case a is just 1. So you can still write it like this. Okay, so these are the same form. In this case, a is 1, so we can just remove the a. And you could call this a different form where the coefficient of x is just 1. And now all we have is b squared minus 4c divided by 2 over here, and the negative b remains the same. Now this plus minus piece over here, in a quadratic equation, we have two solutions, right? And this, let's say we plugged in our values. Now to solve this equation we have, or an expression, we do negative b plus or minus this, and then we do negative b. First we do negative b plus this, and then we do negative b minus this. That's what we're doing here, right? In the numerator here, we're doing negative b minus and negative b plus. So we express it as plus minus. Accordingly, like the same thing in a quadratic equation, if let's say the two solutions are negative 4 and plus 4, we write it like minus plus 4. So this would be like the two solutions. Or you could write it like this, or just 4, whatever. But this is a better form to write your solutions in. Let's take away this quadratic formula. That's done. Now, radical expressions can be very confusing, but we need to talk about radicals. Right, radical expressions where we have square roots, cube roots, etc. Right, if I have, let's say, square root of 2 equals, like, I don't know, y. Another way of expressing this is like we can just square both sides of the equation, gets rid of a square root, and then we have 2 equals y squared. This is a simpler way of expressing a radical. If we have, let's say, some numbers in here, if we have x, y, if I square this product with a radical, this is just equal to x, y. So you can always square the parts of an equation to get rid of the radicals. And that's a useful technique in algebra problems where we have radicals, and an easy way to get rid of them is just squaring the radicals, squaring both sides of the equation. But squaring the radicals includes that. We can also we can square the radicals. What we can also do is fractions. Like if you have something like, I'm just giving an example. Like you probably know how to deal with this, right? We can just multiply everything by x. Pretty simple. We didn't even need, so stuff like that, like getting rid of denominators when it comes to fractions, like getting rid of denominators whenever you see a fraction, it is useful, but sometimes you won't need it. Like if I have, let's say, I don't know, x minus 3/4 x, I could multiply through by the denominator, or I could just rewrite this as 4/4x minus 3/4x, and it's much easier to simplify. So stuff like that you can always use. Algebra is just a big topic, so in math counts you will find types of problems, especially like these two we're talking about today are from the 2015 state competition, I believe, sprint round. But yeah, now we're gonna get started with the problems. You already know everything you're gonna need to know for the problems today. You should watch the polynomials video if you haven't already, okay? Go in order with the lessons, otherwise you aren't gonna know some stuff. So I'll just go over stuff anyways if you don't know. If you square a binomial, so a plus b squared, you square the first term, you take the product of the terms, you multiply the product by 2, and you square the last term. You're going to square out the binomial. Pretty easy, I guess, but that's how you square out a binomial. And again, go ahead and watch the polynomials video if you haven't already. Let's move on to the problems. Alright, first problem comes from the 2015 MathCounts State Sprint Round. All problem credits goes to MathCounts. Number 23. If x plus 1/x equals 3, what is the value of x to the 4th power plus 1/x to the 4th power? Okay, so over here, we have x plus 1/x equals 3. This is pretty good. We have an x in both terms. So we can, over here, what we want to do is we can get rid of this denominator. So I can rewrite this as multiply all terms by x. We're going to get x squared plus 1. Multiply this by 3. X. I'm going to have 3x over here. And now I can just have x squared minus 3x plus 1 equals 0. Have a better plus over here. Plus 1 equals 0. And we rewrote it. We rewrote the quadratic into this standard form. Quadratic equation. We set it equal to 0 because that's what it's equal to. And now all we need to do is solve for x raised to the 4th power and take the reciprocal, raise the denominator to the 4th power, and we'll be done. Take the sum of that. Long process, but that's how you do algebra problems. So we're going to solve this quadratic right over here. Now we just apply the quadratic formula. Negative b, well, b is negative, so that becomes a plus or minus the square root b squared, 9. Now over here, I like to compute the 4ac. A is just 1. C is 1, negative 4. And the coefficient of the quadratic term a is just 1, so that's just 2 in the denominator. And now we have 3 plus or minus square root of 5 over 2. Well, we can't really simplify this radical over here. Now we've solved for x, and now we need to raise this to the 4th power. The 4th power. And then we need to take the reciprocal of this. This answer is not looking pretty good to me. the quadratic approach isn't really working. We have 3 plus or minus the square root of 5 over 2. If I even did that correctly, and we're probably going to make some mistakes as we go along, this is not going to work out. So let's erase all of this. So we're going to approach this problem a little bit better. And I made the mistake on purpose to show everyone common mistakes people will make. Or not really a mistake, but going down the wrong path. There is no need to ever use quadratic formula. We don't even need quadratics for this. Let's take a look at this equation we have over here. Now, how can we get this to look like this? Well, we might do something to both sides. We have an equation, we need to do something to both sides to get this expression over here. Well, we could raise both sides to the 4th power and then find that out, but the 4th power, that's a lot. So what I'm going to do is I'm going to square both sides of this equation right here. Square both sides, and that'll produce an x squared term and then 1 over x squared term. Square the first term, x squared. The product of the terms is x over x, which is 1. 1 times 2 is 2. And then we have 1 over x squared. And all of this is equal to 9. And now we have x squared plus 1 over x squared is equal to 7. Now we're halfway done with the problem. Now to get an x to the 4th, we just square this again. Right? Square both sides of the equation again. Square the first term, get an x to the 4th. And then we have product of the terms, x squared over x squared, still 1. 1 times 2 is 2. We have a plus 2. And then over here we have 1 squared. That's just 1. 1 remains constant. And over here we have x to the 4th power equals 7 squared, which is 49. Now we have x to the 4th power, subtract 2 over there, plus 1 over x to the 4th, 49, 48, 47. We have our answer. And we didn't even need to find x. Well, we did find x, but that was a crazy answer. We had like -3 plus a square root of 5 over 2. It was a crazy answer, which we don't like crazy answers. Obviously, there's a better way to solve every single algebra problem. So, let's move on to the next problem. Okay, so we have the square root of x plus 7 equals 2 plus the square root of x. What is the value of x? Express your answer as a common fraction. Okay. So we can expect our answer to be a little bit crazy, because we need to express it as a common fraction. That's what it means in math counts. Good problem-solving strategy is to always look at the end. Don't be scared if you have a crazy answer, like a decimal or a fraction. Read the end part, and you'll see what you need. We had the square root of x plus 7. I'm going to rewrite the equation over here. Equals 2 plus the square root of x. X plus 7. Now we're asked for the value of x. Now we're going to learn from a mistake. We're not going to go ahead and find x because we have square roots. And well, I don't really know how we're going to do this just by finding x. So we're going to find a better way. So we have a square root. This problem would be a lot easier if we didn't have the square roots involved in it. So we can get rid of the square roots to make this problem 10 times easier. We know how to do that. We can square both sides of the equation. We can square the equation. The square root gets canceled. We have x plus 7. Over here we have a binomial we need to square. Square the first term, we get a 4. The product of the terms is 2 root x multiplied by 2. We get 4 root x. And then we just square root of x squared to give us x. We still have a radical, but it's a lot easier to deal with. We're going to bring all of our x terms over here. So we're going to have x minus 4 root x minus x equals 4 minus 7, which is -3. So now these cancel. So we have -4 root x equals -3. Both negative. We can multiply all terms by -1. We can get 4 root x is equal to 3. So I'm going to rewrite the resulting equation. 4 root x is equal to 3. We want the value of x, so the square root of x is equal to 3/4. Now we have a radical here. We want to find x. To find x, we get rid of the radical square root by squaring the equation all over again. We get x is equal to, we square this, we get 9/16. Can't simplify that any further, so this is our answer. And we turn this equation with a lot of radicals into something a lot easier. Well, we did find the value of x because that's what the problem wants us to, but we didn't do it by solving this equation. We manipulated the equation a bit and expressed it into this, because notice how these are equal. This equation is equal to this equation. So remember, you can always manipulate equations by doing whatever you want to the equation to both sides. Make the equation a lot easier, such as getting rid of your denominators. Like we saw, squaring equations is one of the most useful problem-solving techniques in algebra problems. So, yeah.